Hi everyone, welcome to your very first tutorial on polynomial regression. My name is Shangfa, currently a PhD student in the University of Financial Sciences at the Center for Brain and Market at the University of Melbourne. My research interest is mainly on the computational complexity, general science, and neuroeconomics, specialized in multi-attribute decision-making. For today's tutorials, we aim to first understand polynomial regression, and second, try to structure the structure design matrix that can fit in the polynomial regression. So what is a polynomial regression and why do we need it? Normally in real life, when we have a data set, they are not necessary to be linearly correlated to each other. For example, the one on the left-hand side, if you just fit in a straight line, that won't fit perfectly with those data points. That's why also in neuroscience applications, the relationship isn't strictly linear. For example, how a neuron's firing rate might change with stimulus intensity. That's why we need a polynomial regression model that allows more flexibility in the model by modeling the output as a weighted sum of powers of the inputs. This example just raised to the degree of 2. One benefit of doing so is that you can still use least square or maximum likelihood estimation for model fitting. This is the general regression model. As you can see, you still have your constant, the intercepts. Then start with coefficients by raising the independent variable to the power of k, or the maximum power that you want, plus a random error term. Here are some graphical examples. And you can see when the degree goes up, then more turning points allow in the regression, and it can capture much more complexity in your data sets. However, one thing you need to be cautious is that if you have too many degrees of power, then it may lead to a overfitting. Because in general, with our data points, we want to find a generalizable pattern instead of just fitting what you have on hand. Now let's do a hands-on practice together. Let me find it here. So very good. Of course, when we are going to do something, we can first define a function that we can call it later on. To create a design matrix of inputs in polynomial regression, you will need x, the independent variable, and the order, the maximum degrees that you want to go up to. And first thing first, you need to ensure x dot n dimension is 1, meaning that x is a column vector so that we can broadcast correctly. Then we will initialize this matrix with column of 1s to represent the bias term, x to the power 0. And inside the loop, we'll again raise x to each power from 1 to order as the maximum power that we want to go up to, and horizontally stack them using np.hstack to resulting in the column to the matrix. To test out our code, you can set the order to 5, so maximum power 5, and print out the first 2 columns and the first 2 rows of the code for doing so. Thank you for your time.